Okay, so in a couple previous pages, we've already talked about paths and circuits, but we have a specific type of path and circuit that we would like to talk about on the next couple of pages. So a path that visits every edge, so it's every edge exactly once, is called an Euler path. So the difference between a path and an Euler path is that a path does not have to pass through every edge on a graph, while an Euler path passes through, again, every edge exactly once. Remember that a path can begin and end at different vertices. An Euler circuit is a circuit that passes through every edge of the graph exactly once. So every Euler circuit is also an Euler path. Okay, in an example on the next page, you'll be asked to find an Euler path and an Euler circuit. Well, as I just got through saying here, if something has an Euler circuit, that same thing is also considered an Euler path. So the difference between a circuit and a path is that a circuit must begin and end at the same vertex. So in example 7, I wanted to show you that this particular graph has an Euler path, and I'm going to start at vertex D. And I'm going to take the following route. My first edge I'm going to go to is DA, so I'm going to go from D to A, and then A to B. And the reason why I'm marking these is so you can see I've used every edge. And then B to C. Then I'm going to go from C to F. And then I'm going to go from F back to D. So remember, it's okay to go back to that vertex again with the Euler path. It's the edges I can only use once. And then from D, I'm going to go to E. And then from E, I'm going to go to B. And I think you see that we've used all of these edges except from going from B to F. Okay, I have used every edge on this particular graph. So the path from D to A to B to C, etc., that is an Euler path. So this graph has an Euler circuit. So I'm choosing to start at vertex A. And so, again, if it's an Euler circuit, I need to end up at A. So again, I need to use every single edge exactly once. So I'm going to go from A to B first, then from B to C, and then C to A. I'm not finished because I haven't used every single edge. And I think you might see how I'll be able to finish this up because it's not too hard. So I'm going to go from A to D, D to B, B to E, E to C, and C to F. So let me go ahead and write that down. So A, D, B, E, C, F, A. So how did I know it had an Euler path or Euler circuit? How do I know where to start? Did it matter? Well, as a matter of fact, it does. And so we can use the Euler's theorem. So Euler's theorem will help us figure out whether or not a graph has an Euler path or an Euler circuit. So for any connected graph, if all vertices are even, the graph has at least one Euler circuit. An Euler circuit can start at any vertex. If exactly two vertices are odd, the graph has no Euler circuit, but it does have at least one Euler path. The path must begin at one odd vertex and end at the other odd vertex. If there are more than two odd vertices, the graph has no Euler paths nor Euler circuits.